two things I want to do today. The one I definitely want to do, the next one, if we have time, we'll do it. But if not, we can wait until next week. One thing to notice in Canvas is I lumped 2 weeks together. So if you look in Canvas, you'll notice that I lumped weeks 7 and 8 together. All right. The one day that I was out for my doctor's appointment, we kind of lost a little bit of ground that week. So, plus the difficulty I had with the lecture last week, seemed like we needed a week to sort of catch up and get everything back in line. So I combined what we're doing in this week, we would normally do in week 7, but I combined them to contain 7 and 8. So what we're going to talk today is about validation, and we're also going to talk about LINQ. If you happen to be caught up or are soon going to be caught up with the material, and you're worried about having nothing to do, a couple things to note. The week after week 8, in other words, the week after next is spring break, so you can use that to relax. If you want to work over spring break, you can always look at things dealing with your project and start thinking about your projects. We have enough of a background now, I think, and we'll cover some more of this later, but we have sort of the basics set up for you to be able to start thinking about what you want your project to include. So start thinking about it. Your design is due not too far in the future. Your design is due March 30th. So that would be like roughly 4 weeks from tomorrow. Which seems like a little bit of time, but time flies. All right. So let's look at this tutorial I have brought up. Wrong one. They use the acronym DRY, or don't repeat yourself. And they give a little Wikipedia entry to back it up. DRY stands for do not repeat yourself. And I've sort of brought that up in many cases when I talk about like writing functions or developing classes or whatever, that a lot of what you code is to make your code more maintainable. And what better way to make your code maintainable than to only have to write something down in one place, right? And have it be used throughout the application. I mean, that's what we do with CSS, right? We do not repeat ourselves. We don't have a separate CSS file for every page. The basic CSS file of our site is used on every page on our site. So we don't repeat ourselves, just one file with the CSS information. So that's always a goal in software development. And what we want to do is we want to add validation rules to the movie model. I have a version of that movie model, which I made a small enhancement to that we'll talk about when we get to the LINQ section. But data validation is something we're going to add to it today in class. There's a number of different attributes that you can have. You can have required field, the length of a string, regular expression, and range. And we'll talk about each of them in turn. Let us look at the application, again, which is basically what you did in the tutorial with a bit of an enhancement on the search. And we'll look at that and see how it runs now without any validation, because we don't have any of these annotations in our model yet. So if we go in here, we click Create New. All right. We get these things because the field is required. All right. We don't get an error though for title. Also, if we put in something that doesn't make sense, we get a different kind of error. So I'm going to put a proper date in and a proper price, and we can save it. That's not particularly a good thing to have, right? Because if we save it, and we can save it without a title or a genre, it's probably not good for our application. So we're going to go back and we're going to make some of these fields required by the use of data annotations. And we'll take them a few at a time. So let me bring up the model here. It's interesting that we got those errors despite not giving them an annotation. I believe it's because of their data types that we had to put something in there. And if we put something invalid in, it knows that it's not a decimal or a date. The model knows that is. So let's look at what we can do and what they want. Title. They have two annotations for it. And we'll just copy and paste them over, and we'll look at these one at a time. You put the annotations immediately above the field that you're annotating. So this says that the string has a length of 60 characters, so you can't type in something more than 60 characters, and a minimal length of 3 characters. So you can't type in just 2 characters for a movie name. I don't know if there are any movie names. That's a little bit dangerous, I think. But for demonstration purposes, we'll pretend there's no movies that have less than 3 characters. So now we're going to do this, and we're going to run it, and let's see what happens now. Gives us that the title field is required. What if we type in just a single character? It tells us the field title must be a string with a minimum length of 3 and a maximum length of 60. If we were to type more than 60 characters, it warns us about that. So we can put something in here, and then we're able to save it. Now, interesting thing, we didn't have to touch our code, all right? I did not go back and rescaffold these things. I didn't touch our code at all. Let's look at the discussion about how this works. They have down here how validation works. You might wonder how the validation UI is generated without any updates to the code. They have, if model state is valid, then go and do this, and then return the movie. It describes here a mix of client and server-side code that checks the data annotations for the model to make sure that the model is legit. It talks about if you disable JavaScript, it still works because the server-side code gets to it. So the input tag helper uses data annotation attributes and produces HTML attributes needed for jQuery validation. All right. Let's take a look at some of these other things. You know, now's as good a time as any to look at the database. So far, because we've been doing code first, we haven't actually looked at the database at all. But a database is generated and we can look at it. Now, I just added an annotation to the model movie.cs. I added the required fields. Does that exist in a database? Well, let's see. And I made it required. Let's go to SQL Server Object Explorer. We see our project up here. Oops. And under databases, we see our database. We look under the local server, which is local DB. That's a version of SQL Server that runs on a machine on its own, a sort of a standalone version. We can look at the tables, and we can look at the movie table, look at the columns, and genre and title still allow nulls. Why is that? That is because we made a change to the model and didn't migrate the database. Let's see if it picks it up if we migrate the database again. I honestly don't know if it will or not, or if that's just a code-only thing. So let's go here under Tools, Console, and I'm going to say add migration, validation, does its thing. Then I'm going to do update database. Does its thing. And it did try to update it for null. However, it can't perform the update. Why? Because we already have a row in the database with a null title. So it cannot update it to make it not null. So if I go and get rid of that row, now I should be able to go and do the update. And there it does its thing. And if we look at the columns now, we can see that title and genre still allow nulls. It's weird. Maybe those don't apply to the database. That's weird though, because it complained about it a minute ago, but then it allows us to, but if we change it, it allows us to do it. We got rid of that row, but now it looks like it did it without the error, but it doesn't actually update that. Oh, I know what we got to do. I think I know what we have to do. Let's refresh. Okay, it doesn't like the fact that we're editing the database objects. So let's refresh now. Now, if we look at it, those don't allow for nulls. I always forget about that you have to, if you make a change, if you update the database and you have your Database Explorer up, that change is not immediately reflected. It has the old values until you go and refresh the Database Explorer. Anyhow, you should not be making changes directly to the database. That is, you should not be making changes to the database structure by adding a column, deleting a column, changing these properties, and so on. Why? Because those have to be in sync. The database has to be in sync with the model. Therefore, all the changes that we're going to make to the structure of the database, we have to change the model and then update the database, which is what I did. Now, as far as adding data, I can add a row in here just fine. And boom, it goes and saves it. And now I can see it if I bring it up. So I can add data. I just can't make any changes to the structure of the database. All right. Let's look at the next annotation that we're going to put in here. Always got to keep the model in sync with the database. Notice that nothing was changed as far as the string length, because I don't believe you can constrain the length of a string in the database. That attribute's only for the application only, I believe. All right, let's look at the next one. Display name. Right now, if we run this, for date, it says release date. All right, with no spaces in it. It runs it all together. Why is that? Because that's the name of the field in the model. Name of the field in the model is release date. So by default, it's going to use that name, which is also the database column name, as the title of that field. We can, however, make it display something else. Let's say we want to make it look nice and have a space in there. We can go and we can say display name equals release date. That allows us to get a value different than what the column name is. I also don't think this one's relevant to the database. This is only within the application. But think about it. Think how nice that is. We have right now we have 4 or 5 screens that say release date on them that have release date all run together without a space. We make the change in one place here, and that change gets reflected everywhere in the application. Release space date. I go to edit this. Release space date. See the details. Release space date. Delete it. When it displays it, it says release space date. A great example of not repeating yourself. So anywhere in the application that you use this particular field from that model, it'll format the name the way that you have it entered. All right. Very often you don't want the name to be exactly what the database column is. I worked with a company once that had a list of standard abbreviations. I don't remember specifically what they were, but I remember sort of how they worked. If you had a field like inventory price, they had an abbreviation for inventory. Let's say it was INV. And they had an abbreviation for price. Let's say it was PRC. So inventory price, the column name should be INV PRC. Well, to a user, that doesn't make a lot of sense. Therefore, you could give it a display name that made it more sense, or format it differently or whatever, so that it is more user-friendly. On to the next. With the price, remember that warning that we got? This will get rid of that warning. Oh, I put it in the wrong place. The range means it can only be of a value from 1 to 100. The data type is currency. The column has a type name of decimal. And it's giving me an error on that. Not really sure why off the top of my head. That could be from an older version. I'm going to just delete it. So now when we run this, we give a price that's between 1 and 100, it's okay with it. If we give it a price that is not between 1 and 100, it gives us an error. I can go here and edit. Gives us an error. You give it a price. There it is. Notice because we said the data type was currency, it formats it neatly. And it formats it using the local currency symbol. Because we're in the US, it uses a $sign. All right, just a few more to go, I think. Regular expression. These are complicated. All right. Definitely, I would not characterize myself as an expert in regular expressions, but you can find things online that to help you out here. So for genre, oh, I'm debugging. And the errors go away. A regular expression is a pattern that something must fit. excuse me, what this is telling you is that this is going to be a combination of starting with an uppercase letter and then having a bunch of upper or lowercase letters after it. Let's see if that's true. Let's see if I'm not making this up. If I type in numbers here, it gives a not terribly useful error message. The field genre must match the regular expression, blah, 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 blah. But it does give you an error. I'll look in a second to see how we can get a custom validation message. If I put it lowercase, gives me the same thing. But if I give it a capital A followed by a mix of capital and lowercase letters, boom, we're in business. Now I'm going to search for how I can get a custom validation message. I would assume you're able to do it. Here's a list of more possible annotations that you could use. Error messages. Validation attributes let you specify the error message display for a invalid input. So I would go into the model and say, there we go. So now it's going to display my error message, which hopefully is more user-friendly than theirs. If I type in an invalid genre, it gives my error message saying it's not valid. Please take the time to do this. A little bit of extra work goes a long way in making your project look a lot better and more professional. I think that's it about the basic validations. Oh, I was going to look at regular expressions. They show you the rules for creating them. This is make sure that this is 10 characters. Alphanumeric. This is a little different than the other one because it needs to be exactly 10 characters. Oh no, this I stand corrected. This is a maximum of 10 characters. To enter a 10-digit number only value, a regular expression for that. 5-digit number, only a value between 0 and 9. And a 5-digit number between 0 and 9. That's a little confusing. Email's a good example. All emails fit a certain pattern, right? There are some letters, the @ sign, then the domain name, something dot something. And here's the example of a regular expression for email. Glad that you don't have to think that up, right? That you can find that somewhere. You can develop your own regular expressions if your company or organization had something like a part number, where every part number was maybe a letter followed by 3 numbers or something along those lines. You could create a regular expression to define that pattern and make sure the data was validated up against it. All right. It's a good idea to use these. Remember that this allows you to put the validation rules in one place and they'll be used everywhere throughout the application. Databases offer a lot of great features, but they only do so if the data has integrity. Therefore, by putting validation in there, you can make sure that data is valid. Data is reasonable to some degree, right? If I was putting in a movie and the title, I entered Titanic and the movie was actually Star Wars, doesn't know to validate that. But it can make sure that the title looks like a title, which they define as up to 3 characters. All right. That's it for validation. What we're going to look at now is LINQ. LINQ stands for Language Integrated Query. Okay, what does that mean? Let's look at this one step at a time. It's language integrated. In the old days, if you wrote a SQL statement, it might look something like this. You might have your code. Say something like SQL equals SQL statement equals select customer name. I typoed, but good, we'll leave that in. Sales from customer. And your programs have these SQL statements embedded in them. All right? And this is like the old-fashioned way. What's wrong about this is I could literally have any string I wanted to in between the quotes, and the compiler isn't equipped to understand that this is a SQL statement, and we want to pull this column from this table. So the compiler will accept any string in there, even if there's invalid column names, even if the format of the SQL statement is wrong, even if anything, it's not even a SQL statement. Well, that leads to problems. You're not going to get a compile error in that case. You're going to get what's called a runtime error. Now, in the hierarchy of errors, compiler errors are the errors that you want to get. All right? Ideally, you want no errors, right? But we all know that you're not going to achieve that in the first pass. If possible, we would like our SQL statements to be checked by the compiler. All right? The compiler can't do that. So it pretty much has to accept whatever we typed in for a SQL statement. Then when it executes that statement, it'll give us an error if there's a problem. Well, it's going to give us a problem at runtime. In other words, when the user is running the application. All right? Now this becomes even more complicated because some of these runtime errors are situational. In other words, they don't arise under every situation. They only arise under certain situations, which means that a customer might tell you that they're getting an error on this web page, but you can't recreate it because you don't know the set of steps that they took that screwed up your SQL statement. It's much better if this would give me a compile error and say, hey, there's no such column as customer name. It's customer name. But the old way of doing SQL statements like this didn't work. And the result would be that you'd get runtime errors instead of compile errors. And if there's going to be an error, we want it to be a compile error. Now comes along LINQ. LINQ means that the queries are integrated in the language. This is not a query, this is a string as far as C# is concerned. So you can put anything in there that is a string. If I wanted to refer to customer name using LINQ, I would put the name of the entity and I misspelled it on purpose. I would put that in an instruction that does the query. We're not going to talk about the specifics of the query yet, but I would use that in my query. The good news is the compiler can look at the customer model and say, hey, there's no such thing named customer name, and therefore it would give me a compile error. It'll tell me, hey, that's not a valid column. It will give me that as a compile error, which means that we can find it and fix it before we release it, and it doesn't just pop up on people's screens under some vague circumstances. So that's what we mean by language integrated, right? That you actually can use these things in instruction, all right, as opposed to being just giant strings that contain information. Now, the other thing is that it is queries. Now, we know about SQL queries, or we should. All of you have had the 143 class, I would assume. All right. So you know what SQL statements and queries are. So you know how to pull data out of a database. But a database is not the only place that data can live. Data could live in an XML file. It could live in a list in memory. It could lay as a collection of objects. You don't know. What LINQ allows you to do is to query all these different locations where data could be stored using the same sort of syntax. All right. So we don't have to remember, gee, this is in an XML file. So how do I write this? Or gee, this is in a database. So how do I write it for a database? It does all the queries in a uniform way. So that really is what LINQ is. All right. This tutorial does a good job covering the basics of it. I would focus on, I think I said the first 19 of them, which sounds intimidating, but really each one's just a one-page thing. Here, for example, is how we get a select statement in LINQ. And what they do in most of their examples, as opposed to creating a database, is they create lists. And the query looks like this. From AMP at employee.getEmployees, select AMP to list. And that executes it. This sets up the query and that executes it. And it stores a result in a list. Now there's two ways that you could write a select statement. That was the first way, where it sort of looks like a SQL statement and has some of the same clauses. And this is using, no, I'm sorry. This is using right here. Employees get employees, select employee, give me the employee ID. That would return the same thing. All right. So there's sort of two formats to do the query. One is like a list of functions. One is like a sort of like a SQL query. All right. In the examples that we give, we're going to use the one that is a series of functions. So what I did is I added capability to the movies project, where I allow them to select by price and either select if it's less than or equal to a certain price or greater than or equal to a certain price. So I see now I have a movie that costs 22 and a movie that costs 12. If I put 17 in and say, give me everything that's less than or equal to that, it should give me Indiana Jones. If I change that to greater than or equal to, it should give me Star Wars. So that's the functionality. All right. Let's look at the code that does that. And we'll break it down. All right. And we'll go over this LINQ as we do more and more advanced things. Like when we join tables together, we'll look at LINQ and so on. All right. That code is in the movies index. First of all, from an HTML perspective, I have input link ASP4 search string. ASP4 search type. That is going to connect this HTML to the model. Whoops, not that model. the other model. So I can use the variable search string, even though I don't believe I have it defined. Oh, I do have it defined as a property. But search string and search type, bind property, supports get, true, means that along with the ASP4 sort of marries these fields with that control on the form. So whatever is selected in that form will get put into that variable. So that's what I do on the form side. I have a text box. I have then a drop down with the options, and I connect them by saying ASP4, both of them, and I say support get. Now, this is a basic search query. From M, in context movie, select M. What does that do? That selects every movie in the database. And it gives me this variable. This variable is a list. All right. Now I look to see if the search string is null or not. If it's null, actually I look to see if it's not null. If it's not null, I do these things. If it's null, I just fall through. If it's less than E, if it equals LE, I tack onto that movie list. I query that movie list and substitute into that variable a query that orders those, or rather, I'm sorry, not orders, but selects those whose price is greater than less than the value in the search string. Otherwise, it looks where it's less than or equal to the value in the search string. And then this is sort of the make it so function. This goes and actually performs a query and returns the list and populates this iList named movie that contains a list of movie objects. All right. I'm going to make sure this is enabled in Canvas so you can take a look at it. This query actually combines both the other query styles, both of the query styles together. In other words, this is a SQL looking query, and this is the function based query. So you can mix and match to come up with a query. So what we're doing is we're forming a list that has everything. Here we're looking to see if a search string was entered, and we either filter out if it's less than or equal or greater than or equal. I'll make sure this is posted. All right. I catch the error in case there's an invalid entry. So if I run it, and put garbages in here, gives me an invalid entry, and the rest works. So look over this. We'll spend more time talking about this next week. All right. Are there any questions? Okay. Is anyone going to lab? No. All right.